Hello again, and welcome to 5-Minute Physics. Today's topic is resonance and force vibrations, and we'll be talking about some very specific examples. Alright, so the first thing to know about resonance is that it has to do with a pendulum's natural frequency. Now, a pendulum's natural frequency is the frequency at which it vibrates, due to the length of its string, or whatever it's held on. Every pendulum has a different one, unless there are a couple of identical pendulums, in which case they would have the same one. But the idea there is that the length of the string determines the natural frequency at which the pendulum will vibrate. So for example, here we have the two blue, I always mess up the layers. We have these two blue weights here, and they are the same length. So they would have the same natural frequency. And what that means is that they'll vibrate at the same frequency. So it's called sympathetic vibrations. They're forced. Since one vibrates at this frequency, the other one must also vibrate at this frequency, which would cause the other two to move. That is a forced vibration. That also has to do with that's related to resonance because it's really caused by forced vibrations. Resonance is what happens when the frequency of a force applied to a system matches the natural frequency of vibration and results in a large amplitude of vibration. So resonance is really the frequency at which the vibration is the greatest. So if you've ever been singing in the shower and you hit one note that sounds a lot louder than all the others, you've just found the natural frequency of your shower. Congratulations. So that's how that works. And a very specific example of that would be the Tacoma Narrows Bridge, which you may have heard about, maybe not. It collapsed only a few months after its construction because of vibrations. There was some very strong wind going on that happened to be at the natural frequency of the bridge, and this happened. As you can see, this pretty severe torsional rotation eventually did break the bridge. But that's why modern architecture has to go through a lot of tests related to this to make sure that that doesn't happen. And that's one of the very important applications of resonance and force vibration is architecture such as this. Looks like there's somebody stuck on the bridge there. That's a problem. But as you can see, that bridges are not supposed to move like that. So that is a pretty good example of forced vibration. So back to our diagram, we have these force spheres. So when these move, these are also going to move. They're going to move less, while these might move more. But that would be forced vibration, because these are moving, these must also move. And look, I made a smiley face. Alright, well that's all for today. Thanks for watching, and we'll see you next time.